In this short video, we're going to learn how to derive the total cost curve when we're in the short run. So let's imagine that Clean Getaway produces artisanal soaps that they sell at the local farmer's market. Their production function is given by Q equals L times K, where L is hours of labor hired and K is hours of capital hired. The soap producer is currently operating in the short run, and as a result, their capital is fixed at 20 units. We're also told that the price of labor is $40 per hour and the price of capital is $10 per hour. Our goal is to determine Clean Getaway's long-run total cost curve. What do we need to know to determine this? We need to know the production function as well as the amount of the fixed input. And if we're lucky, we will also have a wage and rent value. If we're not lucky, we'll have to use W and R as placeholders, and we'll have a lot more exogenous variables hanging around in our final solution. How are we going to go about solving this question? We're going to have to meet our isoquant condition, so production has to meet our production goal. We will also have a short run constraint. In this question, it's that K is fixed at 20, but in an alternative question, we might see that labor is fixed at some value L bar. In addition to the isoquant condition and the short run constraint, we also have the total cost function, where total cost is the wage times the labor demand plus the rent times the capital demand. So really this is sort of like a input demand question with one additional step. After we find the input demands, we plug them into our total cost function to form how total cost depends on Q and potentially the unspecified wage and rent. Let's solve this question. Here's what we know. We know the production function. We know capital is fixed at 20 and the wage is 40 and the rent is 10. We are trying to find the short run total cost curve. I think the most important detail here is that in the short run, we do not have a tangency condition. We throw that out the window, and we replace our tangency condition with a short run constraint that capital is 20. So we still need to meet our isoquant. You can think of this isoquant condition as a production constraint. So the production constraint here is that L times K has to equal some unspecified output goal Q. Then we have our short run constraint, which is that capital is fixed at 20 in the short run. So we'll call the isoquant condition equation 1 and the short run constraint equation 2. From this isoquant condition and short run constraint, we should be able to solve for the demand for labor. And with the demand for labor and the short run constraint, we can find the total cost function. So let's lay down the sort of baseline formula for this total cost function. Total cost is always equal to the wage times L star plus the rent times K star. So filling in what we know, we have total cost is 40 times L star plus 10 times K star. We'll call that equation 3. Once we write down all these things that have to be true along the long run total cost curve, solving it actually becomes pretty easy. The first thing we'll do is we'll substitute our short run constraint, K equals 20, into our isoquant condition and solve for L, and that will be our labor demand curve. So all this means is in place of K, I'm going to put 20. So I have L times 20 is equal to Q. Solving that for L, I get L is equal to Q divided by 20. If you want, you can recognize that this is L star of Q, the short run demand for labor. We can call that equation 4. From here, we just need to plug in what we know. We know that K is 20. We now know that L is Q over 20. And we can plug that K equals 20 and L equals Q over 20 into equation 3, the total cost function, and we'll have a total cost curve that depends only on Q, the output goal. So total cost is equal to 40 times L star, which is Q over 20, plus 10 times K star, where K star here is just fixed at 20. And we do a little bit of simplification. The 40 cancels with the 20 and becomes a 2. So we have a total cost function, which depends on Q, is equal to 2Q plus 200.